All right, we are on our second review video, beginning with number 12. So if you have not done 1 through 11, please go back and look at that video. Let's look at number 12. Neil goes to the pet shop and he selects 2 treats for his dog, chooses one, puts it back on the shelf, and then chooses another. So what is the probability that he selects a bone and then a ball? So when he puts it back on the shelf, that is with replacement. Let's just make a note about that. Okay, and we want the probability of a bone and then the probability of a ball. Okay, let's just count these really quickly to get a total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 treats total. So the probability of a bone, 1, 2, 3, 4. So 4 out of 12. The probability of a ball, 1, 2, 3, 4, 5. So 5 out of 12, and they both say 12 because remember we had with replacement. I can simplify this a little bit further and that can become 1/3. 1 times 5 is 5, 3 times 12 is 36. So the probability of a bone replacing and then selecting a ball is 5 out of 36. Okay, let's look at number 13. Students standing in line for a theme park were surveyed about their favorite ride. Their responses are shown below. If one student picked randomly, then which of the following is true? Let me zoom in a little bit to make that a little bit easier to see. There we go. Okay, so we have a total here of, what is this? 14 and 8 is 22. 22 plus 28 is 50. So there are 50 total. The student's favorite ride is half as likely to be a live show than a roller coaster. So for live shows, we have 8 out of 50. Okay. And the probability of a roller coaster is 28 out of 50. So half of 28 is 14, so that's not going to work. The student's favorite ride is more likely to be a carnival game than a roller coaster. Well, the roller coaster is 28 out of 50. The carnival is going to be 14 out of 50. So they are more likely to like a carnival of 14 than a roller coaster of 28. This is also not true. The student's favorite ride is twice as likely to be a roller coaster, so 28, than to be a carnival game. So is roller coaster 2 times a carnival game? Well, 14 times 2 is 28, so I bet you it's going to be H, but let's just look at J just in case. The student's favorite ride is twice as likely to be a carnival game. So we have 14 as a live show. Well, 8 times 2 is 16, and that's not 14, so it's going to have to be H for this one. Okay, so yes, we had a couple of different probability statements, and we've answered our question, so we can move on. Let's look at number 14 and see if I can get it to fit in the little square. All right, cool. An ice chest at a birthday party has a variety of drinks. If you randomly select a drink, do not replace it, and then randomly select another drink. What is the probability of selecting a lemon lime? So the probability of a lemon lime. And then the probability of orange without replacement. Do not put it back. All right, so we have 6 and 6 is 12 plus 8 more, so there's 20 total. So the probability of a lemon is 6 out of 20. Okay, then we do not put it back. And this time we select an orange, so this would be 6 out of 19. So guys, we can simplify this. They are both divisible by 2, so that makes this 3 out of 10. Over here, it's a little bit harder because 6 and 19 don't have anything that they are both divisible by. So we're just going to multiply straight across. 3 times 6 is 18. And 10 times 19 is 190. You could at least divide both of these by 2. That would give you 9 over what? 95. And then we could stop right there. Okay, so the probability of getting a lemon soda, not replacing it, and then doing a orange soda is going to be 9 out of 95. And I don't know if I moved that enough for you to see it. And I think I wrote after the box. All right, my bad. So lemon, lime, just to recap. Lemon, lime, 6 out of 20, which then becomes 3 out of 10. For orange, because we are not replacing, that would be 6 out of 19. We multiply straight across, that would give us 3 times 6 is 18, 10 times 19 is 190. Those both simplify by 2, which gives us 9 out of 95. Okay, I'm going to make it a little bit smaller for 15. Okay, number 15. A spinner with 5 equal parts is labeled 1 to 5. What is the probability that we will not spin a 4? The probability of not a 4 would be 4 out of 5, because there's only 1 4 out of 5 opportunities, and 4/5 is equal to 80%, which is A. Number 16. Oh, okay. A laundry basket has 24 shirts in it. 4 are navy, 12 are red, and the remaining are white. Well, 4 and 12 is 16. There are 24 shirts, so 8 are white. Find the following probabilities of choosing one shirt at random. So the probability of a red is 12 out of 24. We can simplify that to 1/2. The probability of not choosing a white would be 16 out of 24, because it's everything not including white. And we could simplify that to be 2/3, because they are both divisible by 8. And then the probability of choosing a green is 0 out of 24, or impossible, because there are no green. A wedding planner creates a table to keep track of the meal that each guest selected. Which of the following statements is not true? So we have a vegetarian meal with 18, a chicken with, it looks like, let me zoom in, 54, and then a seafood with 27. So my total here would be, all right, 18 and 54 is 72 plus 27 is 99. All right, so a guest, we're looking for the one that is a not true. A guest was half as likely to choose seafood than chicken. So the probability of chicken, let me zoom out now that I can read. Okay, so the probability of chicken is 54 out of 99 compared to seafood, which was 27 out of 99. So is 27 half of 54? Yes, so this is going to be a true statement. A guest was more likely to choose chicken over vegetarian or seafood. So if we combine vegetarian and seafood, chicken is 54, right? So if we combine vegetarian or seafood, that would be 18, 45. More likely to choose chicken over vegetarian and seafood. That is also true. And then for C, a guest was 3 times as likely to choose vegetarian than chicken. Well, no, they were 3 times as likely to choose chicken than vegetarian. So this one would be the one that is false, C. All right, a couple more. Number 18. The spinner below is spun. What is the probability of spinning not a 6? So everything else but a 6. There are 7 possible options. Without the 6, that would be a 6 out of 7. I'm going to turn this into my probability statement. Okay. Okay. The probability of a 3 or a 4 would be 2 out of 7. And the probability of an odd, 1, 3, 5, and 7 are all odd. So the probability of an odd number would be 4 out of 7. Our probability statements are all above. Okay, let's look at 19. One card from a deck of cards is selected, replaced, and then another card is chosen. What is the probability that the first card is black and that the second card is a red card? All right, so we have the probability of black and then the probability of red. Okay, half of them would be red, half of them would be black, and there are, I believe, 52 cards in a deck. So 27 of those 52 would be black. And then if we replace it, so this is going to be 1/2, okay? And then 27 out of the 52 are going to be red. That is also 1/2. So the probability of doing a black, replacing it, and then choosing a red would be 1 out of 4, because 1 times 1 is 1, 2 times 2 is 4. In our probability statements, guys, 1 is right here for black, and 1 is right here for red. All right, number 20. This table shows the snacks in Melissa's pantry. She has granola bars, chips, and fruit snacks. If we add those all together, there are 12 total. What is the probability that she will choose a fruit snack? So the probability of fruit is equal to 5 out of 12. Puts it back, so with replacement, and then chooses granola. So 5 out of 12 times, we move this up a little, we can simplify that to be 1/3. This is going to be 5 out of 36. All right, and then finally, guys, use the space to write down anything that you want to remember as you review for this test. Remember that this review is due the day of your test. You can come see me next week with any questions.